All right, Richland Rams, we're going to go over your homework today for Tuesday, April 27th. All right, number 1 says a card game requires that you have a sum of 5 in order to win. Based on the cards shown below, will Cameron win the game? All right, so Cameron has to get a sum of 5 in order to win. So sum indicates that we are adding these together, and we also have to follow our integer operation rules. So you can find your integer operation rules starting on page 27. I think they go 27 through 37. Okay, so here we go. We are going to get started. All right, so I wrote all the numbers down already so we can add them together, and I also like to bring them down as I go because it does organize my work, and I am sorry that it kind of goes into where the name is on the homework. But if you would please just follow along. Here we go. So we have 3 plus 11, which is 14. And then I brought everything down. Then I have 14 plus negative 5. So if we remember here, we are adding numbers with 2 different signs. So I have 14 plus negative 5. And I carry the sign of the bigger number, which is 14. So that's 9. Mark those out. And then I have plus negative 8 plus negative 2 plus 1. Now, I have 9 plus negative 8, so I still subtract and carry the sign of the higher number. So that becomes 1 plus negative 2 plus 1. So right here I have 1 plus negative 2, which becomes negative 1, because now the absolute value of negative 2 is 2, so it's bigger than 1. So negative 1 plus 1. Now I'm adding a number in its opposite, and that gives me 0. All right, so now we can go answer our question. So 0 is less than 5, so no, Cameron, he did not win the game. So our answer is going to be D. No, because he has a sum of 0. All right, moving on. Number 2, a bike travels 24 miles in 3 hours. At this rate, how many miles will the bike travel in? Okay, so we have a rate question here. This means that we are comparing two different things here. So we are going to set up a ratio table. All right, so we are going to have hours to miles. And the information that it gives us in the word problem is that we have 3 hours to 24 miles. Now, our question asks us how many miles will the bike travel in 10 hours. So we want to make sure our hours go all across the same row. So we're going to have hours. We have 3 hours, and then we have 10. Okay. Also, if you have any questions, this is found in 49 through 50 in your math journals. Okay, I'm going to change the color here. All right, now we ask ourselves, how did you get from 3 to 24? Well, we multiply by 8, and remember, what I do to one side, I have to do to the other. So we have 10 times 8, and that gives us 80. So 80 miles is our answer. B would be our answer. All right, number 3. A survey shows that 85% of the students carry a backpack to school. If there are 320 students in the school, then how many students carry a backpack? All right, so we can see here that we have a percent in our question, and then we have a total number of students. So this is going to be a percent proportion question, which starts on page 55 in your math journal. So we are going to set this up as our percent proportion. So we are going to have a part over our whole equals 8% over 100. So we have our percent, and we are looking for our part. And then we have our whole, which is 320. Now what I like to do is I notice that my whole is greater than my 100, and I know that these are equivalent to each other. So I'm going to switch them. I'm going to put 85% over 100 and set it equal to my part over 320. I also know that 85 and 100 end in 5 and 0. So that means that they are divisible by 5. So I'm going to simplify to make my numbers easier to work with. So 85 divided by 5 is 17. 100 divided by 5 is 20. Now I can scale factor a lot easier. So I have 20 to 320. I know that 2 times 16 gives me 32, and I just have a 0 at the end of the 20, so my scale factor is going to be 16. So what I do to the bottom, I must do to the top. So that's 17 times 16. 17 times 16. Well, that's 42. Carry my 4. 6 times 1 is 6 plus 4 is 10. 0, my placeholder, and then I have 1 times 17. So this gives me 272 students that carry a backpack to school. So my answer is D. All right, number 4. Mr. Dorado has completed 75% of his morning run. Which of the following sets does not represent 75%? All right, here we go. We are going to do what is called a brain dump. If you ever have any problems with this question, I would do a brain dump. This is also in your equivalent fractions, decimals, and percents in your math journal on page 53, 54. So a brain dump is just writing everything that you know about a certain concept or a thing. So I'm going to write down 75%. I know that percents are out of 100. So I know that the decimal comes at the end of 5. I'm going to make 75% a decimal. So I move it 2 places to the left. So that becomes 75 hundredths. And then I also know that if I want to make 75 hundredths a fraction, I make it just like it says. This becomes my numerator, and my denominator is the place value of the 5. So that's 75 hundredths. And then if I simplify this, and I divide by 5, and I divide by 5, I end up getting 15 over 20. So I already know that B is true. And if I go any further, if I divide by 5 again, I end up getting 3/4. So A is true. Then I know that if I end up multiplying by 3, I'll get the equivalent fraction 9/12. So D is true. And I know that if I made 75% a decimal and I went 2 places to the left, C could not be true, so C is my answer. All right, here we go. If the shaded strip diagram represents 100%, then which strip diagram represents 150%? Okay, so I need to know this whole strip diagram is 100%. So I'm looking for a model that's going to have this as a whole, and then it's going to have another one because I'm looking for a diagram that represents more than 100%. So I can go ahead and mark out B. I know that A is not going to be my answer because I do have 100%, but if I go and half it, this is not all shaded in, so A would not be my answer. If I look at C, I do have the 100%, and this is right in the half, which is 50%. Also, 1, 2, 3, 4, 5, 6. This is 3 out of 6, which is equivalent to 1/2, which is also equivalent to 50%. So my answer is C. Good job. All right, moving on to number 6. All right, number 6 is writing equations. So here we go. We started this on page 66 through 70. Burger Town sells cheeseburgers for $7.95 each, plus the cost of a soda. S. Which of the following equations best represents the cost of a meal? All right, here we go. So we know that the cost of a soda is going to be S, and then we are adding it to $7.95 because we have to add it to the meal, and that is going to equal our cost. So our answer is D. All right, number 7. Which expression is equivalent to 4 times 2x plus 3. Okay, this goes with our property of operations. Starts on page 63 in your math journal. We need to remember, what property is this? This is our distributive property. One thing we need to remember is if we have a number that is smooshed up to the parentheses, that means to multiply. But we also need to remember we need to multiply the number on the outside of the parentheses to every term inside the parentheses. And then we bring our operation symbol down with it. So this means we have 4 times 2x plus 4 times 3. So remember, 4 needs to be multiplied to every term inside the parentheses. It's distributive property. So then I have 4 times 2x. And since I am multiplying, and I don't know what x is, I just combine them together because it is multiplication. And remember, this means I'm multiplying together when the variable is smooshed up to the number. So that's going to be 8x plus 4 times 3 is 12. So 8x plus 12. So my answer is B. All right, moving on. Number 8, equation models. Here we go. Which of the following expressions is best represented by the model below? Now here we go. This is where we have the algebra tiles, which we started when we started doing equations. Again, it's page 66 through 70 of your math journal. It covers the equations and inequalities. Okay, so remember, the algebra tiles, when they have the x, that means you are multiplying how many you have. So when you have 1, 2, 3, means you have 3x. And these represent what you're adding or subtracting by. Remember when you have your negatives. But if I have a -1 and a +1, those cancel out because those are your 0 pairs. Then I have another 0 pair and those are going to cancel out. Now I have 1, 2, 3, 4, 5, 6 positives. So it's going to be a +6. So let's go look for my answer that has 3x plus 6. And that is B. So my answer is B. Good job. All right. Number 9. Number 9 says if x equals 5, then which inequality is true? So this means that if I have x equals 5, I'm going to substitute x in my inequality. That means put in place or replace x with 5 in my inequality to see which answer choice is true. Okay, so let's go do that. A, I have -2 times 5, because remember when it's smooshed up to the variable, that means to multiply, is greater than or equal to 12. So this becomes -10 is greater than or equal to 12. That is false. Then you're going to have 5 minus 2 is less than 7. That becomes 3 is less than 7. That is true. So B is going to be your answer. All right, here we go. Number 10. Number 10 says 2 piggy banks have a sum of $36.50. The first piggy bank has $13.75. How much does the second piggy bank have? Okay, so I'm going to set this up as an equation because it says that 2 piggy banks have a sum of $36.50. So that means I'm adding 2 things to get a total of $36.50. So the first piggy bank is $13.75. And then I'm going to say let S equal second for this second piggy bank. And put S. All right, now I'm going to solve to see how much is in the second piggy bank. So I'm going to use inverse operations because remember, there's a given positive right there. And I have to cancel out $13.75. And to do that, be a minus $13.75. And what I do to one side, I must do to the other. 75. So these cancel out. Remember, my goal is to get the variable by itself. So S equals 5 14. Carry down my decimal. Gonna make that a 5. Excuse me. And then 3 minus 2 is 2. So the second piggy bank is $22.75. All right, good evening, Richland Rams. Y'all have a great evening.